Hello friends, hearty welcome to you. In the last session we have looked into concept and derivation of integration by parts. In this session we will look into some examples. Let us say we want to find out the integral of x into log x. Also we want to find out the integral of x into sin x. First let's write down the formula. We know the formula is integral of product of two functions. Let us say the functions are f of x and g of x is equal to first function, that is f of x, multiply that with integral of g of x dx minus we have an integral again. After that we have to take derivative of the first function which we left alone, that is f dash x, and multiply that with integral of g of x, and for the whole thing we need to take integral. So that's how we find out the integral of product of two functions. Integral of f of x into g of x equal to f of x into first function, leave it alone, then take the integral of the second function, multiply that, minus of a integral of product of f dash x and first function derivative, multiply with second function integral. Whatever the value you got, for that we have to again do the integral. So if you look at the problem, integral of x log x and x sin x, let's take x log x. What's the integral of x log x we want to find out? So now we have to choose which function as first or which function as second. If you observe, the first function will be as it is, you will do only derivative of the first function. But the second function you have to do the integral. Now if I take log x as second function, I don't know the integral of log of x, so I will take log x as first function and the x as second function. So the next step will be first function, that is log of x as it is, then multiply that with integral of second function, that is integral of x dx minus we have a integral, then we have product of derivative of first function. What's the d by dx of log x? We'll find it out. D by dx of log x, that we have to multiply with integral of x, and this whole thing you want to do the integral again. So that's nothing but equal to log of x will be as it is, integral of x is x square by 2, so can I say x square by 2 log of x minus we have integral d by dx of log x is 1 by x, that I have to multiply with integral of x, that is x square by 2, and this whole thing I have to do integral. So the next step will be x square by 2 log of x minus x will go x times. Can I take 1 by 2 out? I can say integral of x dx, which is next step x square by 2 log of x minus integral of x is x square by 2, so we can say it as 1 by 2 into x square by 2, that is x square by 4 plus c minus x square by 4 plus c. If you observe now, in this particular case we have taken log x as the first function. Okay. Now let's go to another function, the next one, that is x sin x, and see can we take x as the second function in this particular case also. Why are we doing this? We just want to arrive at guidelines like which function to be taken as the first function. Is there any precedence? Which one to be taken as the first function? What are those criteria that we want to understand? To understand that, we have taken x log x. Unfortunately, we don't know the integral of log x very easily. So we have taken log x as first function, and we know when we take derivative it will become 1 by x, and you multiply with integral of x is x square by 2. You should be able to get the solution easy. Now let us take integral of x sin x and see what happens. Let's see integral of x sin x. Like what we did earlier, we will take sin x as first function and we'll leave x as second function. So what's our first step? We have to take first function and write it as it is, that is sin of x. Then we have to do integral of second function, that is x dx, minus, we have a big integral, then we have to find out the integral of product of derivative of first function. So d by dx of first function is sin x, that we have to multiply with integral of second function, that is integral of x dx, and this whole thing we have to do integral. So that will be nothing but equal to integral of x is x square by 2. So we'll have x square by 2 sin of x minus d by dx of sin x is cos x, and integral of x is x square by 2. We have dx. So if you observe now, we started with x to the power of 1 and we went into x square by 2. If you continue this, you go to x cube and x power 4. That means we are not trying to approach the solution, we are actually complicating it more. That means this approach is wrong. That means I cannot have always x as my second function. So let's try to understand now in which scenario I should have x as first function, in which scenario I should have x as second function. Before doing that, we will try to solve the same problem by interchanging the first function as x and the sin x as the second function and see what happens now. Let's write it down. We will say integral of x sin x, now dx. Our first function is now 1 and our second function is sin x. First function is x. Okay. Now my first step will be 1 left as it is. Then multiply that with integral of sin x minus of, we have an integral. Then after that I have first function derivative, that is d by dx of x, and multiply that with integral of second function, that is integral of sin x dx, and this whole thing I have to do integral. Now let's see what happens now. X into integral of sin x, we know integral of sin x is minus cos x, so I can write minus x cos x minus integral of dx by x is 1, multiply with integral of sin x is minus cos x again, minus minus will become plus. So next time I have to do integral of cos x. So let me do the next step. The next step will be minus x cos x plus integral of cos x, that's equal to sin x plus c. So we understood that if I take x as the first function, we are able to arrive at the solution. But if I take x as the second function, we are unable to get to the solution. So what are the guidelines we have to follow? So let's try to understand that. The guidelines are pretty simple. Number 1 is always algebraic function is number 1, except in cases where you have inverse functions or logarithmic functions. In this case, number 1 is taken by inverse or logarithmic functions. So always algebraic functions are number 1 functions to be considered, except the cases where you have also as part of the product inverse function and logarithmic functions. In that case, we don't know the integral of them, so we will be taking them as the first function and the algebraic function becomes the second function. That's what we have seen in case of integral of x log x. We have taken log x as number 1, whereas integral of x sin x we have taken x as the number 1. So can we summarize this our discussion whatever we had? Yes. We can summarize this by a simple way of remembering is ILATE. What's the meaning of that? How to find out the which function to be taken as the first function if there are two functions. Now check what are those two functions. Is it one inverse and one algebraic? Then inverse is the number 1 function. Is it logarithm and algebraic? Then logarithm comes first. So logarithm is the first function. Is it algebraic and trigonometry? Then algebraic is the first function. Is it algebraic and exponential? Then algebraic is the first function. So if you remember ILATE, you should be able to easily get which function to be taken as a first function. So let's leverage that and try to do one example. We have done, if you observe, we have done algebraic function with logarithmic functions. We have done algebraic with trigonometry. We will do algebraic with exponential. Then we will do algebraic with inverse, so that we just look into each one of them. Let's go to the next one. Let's look at integral of x into e power x dx. Now we have one algebraic function and we have one exponential function. So let's look at ILATE and see which one comes first. Algebraic function comes first in the precedence. So that means this is number 1 function and this is number 2 function. So let's write down our formula. We have integral of x e power x dx is equal to, the first function we will leave as it is, then we multiply that with second function integral, that is e power x dx, then we have minus of, we have big integral. After that we have to do derivative of first function, that is d by dx of x, and multiply that with integral of second function, that is e power x dx. This whole thing we have to do integral again. So the next step will be e power x integral is e power x only. So we can say x into e power x minus integral of d by dx of x is 1. Multiply that with integral of e power x is e power x dx, which is nothing but equal to x into e power x minus integral of e power x is e power x plus c. Now if you want, you can cross check. Take x e power x minus 1 into e power x. Whatever we got now, that's equal to x minus 1 into e power x. This you can try to take derivative of this. Find out the derivative of this function. It will be nothing but equal to x into e power x. Now in this case, if you observe, we have taken algebraic function as the first function because exponential have least precedence when compared to it has least rank when compared to the algebraic function. So let's look at one more. We have looked into algebraic with logarithmic, trigonometric, exponential. Let's look at inverse. So we will see one simple example of x into sine inverse x and see how to find out the integral of that. Let's look at this. We have to find out the integral of x into sine inverse x dx. Now algebraic function is x and inverse function is I. Now which one has more, which one is has more rank, we can clearly see that I is the candidate for first function. Obviously by common sense also, we don't know the integral of sine inverse x. We know we can find it out by maybe a little bit of effort. We should be able to find it by integration by parts, but that will be complicating the problem. So we will take inverse function as number 1 and the other function as number 2. So our next step will be integral of first function is sine inverse x and multiply that with x, which is equal to first function. I will leave it as it is and multiply that with integral of second function, then minus integral of product of first function, that is d by dx of sine inverse x, and that you multiply with integral of x dx. So the next step will be integral of x is x square by 2. So we know that x power n is x power n plus 1 by n plus 1. We have x square by 2 sine inverse x minus integral of d by dx of sine inverse x is 1 by root of 1 minus x square. This I have to multiply with integral of x, which is equal to x square by 2. Then I have to find out this particular integral. So let's try to get this 2 out and see, shall we use any method to simplify this. Actually we can use root of a square minus x square in the numerator, but that we haven't found that particular function. So we'll try to use trigonometric substitution and trigonometric identities to solve this problem. So next step will be x square by 2 sine inverse x minus, you take that 1 by 2 out, you have integral of x square by root of 1 minus x square dx. Now what we will do, we will take x equal to sine theta. That gives me dx equal to sine theta derivative is cos theta d. So dx is cos theta d theta. We also have root of 1 minus x square is equal to cos theta. You can just substitute in the formula. So the next step will be x square by 2 sine inverse x minus of, we have integral x square is sine square theta, and what is dx? Dx is cos theta d theta divided by root of 1 minus x square, that is root of 1 minus sine square theta. This is nothing but equal to x square by 2 sine inverse x minus half integral of sine square, root of 1 minus sine square theta is cos theta. So can I say sine square theta and multiply that with cos theta d theta divided by cos theta. We'll write down this step again. It's not clear there. X square by 2 sine inverse x minus half integral of sine square theta, multiply that with cos theta d theta, and in the denominator we have one more cos theta. So cos theta will cancel. We are left out with sine square theta. We don't know how to find out the sine square theta integral, but we know that sine square theta can be written as 1 by 2 into 1 minus cos 2 theta. This is how to find out the integral by using trigonometric identities. So sine square theta, the powers we don't know the integral, but for the multiples like cos 2 theta we know the integral very easily. So we'll convert this, we'll write it as x square by 2 sine inverse x minus 1 by 2 into 1 by 2. So can I say 1 by 4 integral of 1 plus 1 by 4 integral of cos 2 theta d theta. This is d theta here. I hope you are okay with that step. That is minus 1 by 2 into 1 minus cos 2 theta by 2. That is minus 1 by 4 d theta plus 1 by 4 cos 2 theta. Because sin square theta can be written as 1 minus cos 2 theta divided by 2. We can write it like that. So our next step will be x square by 2 sin inverse x minus integral of d theta is theta. So can I say theta by 4 plus 1 by 4 into integral of cos theta is sin 2 theta by 2. Next step will be x square by 2 sin inverse x minus what is theta? If x is sin theta, then theta is equal to sin inverse of x. So can I write it as sin inverse x by 4 plus 1 by 4 into sin 2 theta. I don't know what's the value of sin theta, but I know value of sin theta cos theta. So can I write it as 2 sin theta cos theta? We know this identity, sin 2 theta equal to 2 sin theta cos theta divided by 2 plus c. We'll go to the last step, that is x square by 2 sin inverse x minus sin inverse x by 4. We can take LCM there. How we can do that? We can write this as 2 by 2. So you will have 2x square minus 1 by 4 sin inverse x plus 1 by 4. 2 will cancel. Sin theta is x and cos theta is root of 1 minus x square divided by 4 plus c. So let's summarize what we have learned in this session. In this session we just recap whatever the formula we understood, that integral of two functions is equal to first function into integral of second function minus integral of product of derivative of first function and integral of second function. Simplify that, and for that we have to find out again integral. So this is how we do integration by parts. So in this session we tried to understand which function to be taken as first function and which function to be taken as second function, and we understood that whenever the product of two functions are having either inverse or logarithmic function, then they will be always first function. Other than the remaining cases, always the algebraic function or the polynomial will be the first function, which will help us to solve the problem easily. So remember ILATE. Whenever you have two functions, compare with them, just find out their ranking. I is 1, L is 2, A is 3, T is 4, E is 5. If your rank is less, then you are the candidate. That means you are first in the position. So that's how we have done some simple examples. We'll continue to do more intermediate level examples in the coming sessions on this exciting and interesting topic, integration by parts. So I'll catch you again in the next session. Thanks for your time and support. As always, bye for now.